there is Rod.
Welcome everyone to this week's IPLD sync meeting. It's June the 8th, 2020, and as every week we go over the stuff that we've done in the past week and the stuff that we might work on, and also discuss any items or questions there might be. And yeah, so I start with myself. Last week I finally found really some time to put on the Rust IPLD stuff. There's currently a PR open which adds custom code tables, which means that things are then fully generic. So you can just say, okay, for example, IPFS uses its own table which supports DEC protocol buffers, DEC and DEC keyboard. They don't care about DEC JSON, for example. Or you build a special purpose application that only works on DEC JSON or your own codec, and you can pass in those kind of like tables and implementations, and then you don't bundle the whole thing. And now, like with this PR, the code is so generic that it just works with those stuff if you implement the right traits. That's a huge step. And also then enables me to work on the blog API. So currently the blog API is still on its separate, like small tooling application stuff, but then also the blog API should move into the core of IPLD. This is what I work on next, but now I'm really close. So all the other stuff that I've needed for the blog API should be in when this PR is merged, and it looks good that it will be merged soon. Other than that, I also did a bit of work on multi-base. I mentioned multi-base because it seems that the IPLD team is more and more owning the multi-format stuff as well. So I guess it's also like fair to mention in the meeting is that recently multi-base got support for base 36. Also Peter was involved quite a bit, and I just also implemented it for Rust, and then found out that the text fixtures could need some cleanup, and I did those, and just basically got over it, looked into it, and also we have had discussions about should the base encodings that have only one kind of like lowercase or uppercase characters be case insensitive or not. So if you are into those discussions, feel free to join. And so this was also stuff. And then I did a bit of file code work, which is not interesting for this meeting. And that's, I think, basically it. Next on my list is Peter.
I'm mentioning a small utility that I'm writing that interfaces with the Dagger utility that I already finished. Basically, what this does is kind of like IPFS add recursively from a directory, but does additional multi-threading and reading from the file system in a streaming fashion quicker, and additionally implements various what I call repacks, so that I can easier demonstrate what happens when you decompress parts that can be decompressed within your, let's say, Debian files or stuff like that, and what is the effect on this, while at the same time keeping the resulting files usable. So, like for instance, deb files can actually be uncompressed and can be verified and so on and so forth, while at the same time being deduplicated. So it's kind of what I'm working on, and also what Volker mentioned with the multi-base stuff. There is also an interesting discussion that I started, and I just linked Rod to it earlier. I'm pretty sure that he didn't have time to read it yet. What can we put on the DHT reasonably these days? So, like for example, the Bitcoin work, like how much of that can we actually put on the network to be available? And the answers to that are a little bit concerning, but we can sort of circle to this in the after the updates.
Cool, thanks. Next on my list is Rod.
Okay. My list is, so there's three main things, but also a bunch of just little things. So still working on Bitcoin docs for the specs repo. That's tedious work, but it's like I have to get this stuff out of my head and into the specs doc. And it's fine. It's not. There's no big deal there. It's just a matter of actually writing coherent documents that are structured well enough to describe what's going on at a sufficient level. So I'm working on that. Just bits and pieces of it. Keep on going back to it. Started working on Zcash. Dumped their blockchain. Thankfully, it's much smaller than Bitcoin and much faster. And so far things are going smoothly. My code's not up to scratch for decoding and encoding, but it's a lot of the way there. And a lot of the other utility stuff that I wrote to manage the Bitcoin blockchain just translates directly over. So that ends up being making it much smoother so far. So that's good stuff. There was no, I will skip that one. I've also started looking at Tim's selector syntax and doing that in Go. Tim's having a lot of trouble at the moment with bandwidth, being able to get anything meaningful done. And so we need this selector syntax, the shorthand and the longhand string syntax parsable into Go data structures. So I've started that, and then and just that process of jumping from language to language when you've been deep in one, a little bit jarring to get back to Go again after a few weeks very deeply in JavaScript. So balancing those things, trying to get meaningful work done. That's me.
Thank you. Next on my list is Michael.
Hello. Yeah, so I didn't get a lot done last week just because my back was hurting and I had a lot of like manager stuff to do. So yeah, other than kind of writing up Google Docs, I didn't really get much code done, but a little bit sort of end of last weekend and today, I've gotten some JS multi-format stuff done. So I got some of Rod's work merged and some other stuff reviewed, and early reviews started on it, and merged in some documentation, like a nice table of all the plugins that we've been writing. And then DegCbor is ported now to JS multi-formats, and now I'm working on the rest of them. Right now, I've actually got the SHA-3 stuff up for the multi-hash side of it. Which reminds me, Rod, did you have to do any like hash functions or anything like that for the new multi-format stuff or for Bitcoin, or was it all just straight up codec work?
Yeah, there's a new hash function that comes with the Bitcoin codec. So when you add the Bitcoin codec, it adds a double SHA-256.
Oh, okay, but that's part of the Bitcoin bundle. Okay, cool.
Yeah.
Okay, all right. Oh, interesting. I'll think about how to document that.
Didn't you have to do also the repend 160, or that's not part of the blockchain?
It's not part of CIDs or anything, so it's
Okay.
it's just decoding for fields. So, but the only one that you require for CIDs for Bitcoin, thankfully, is double SHA-256.
Interesting. I wonder if we want to make that its own library, if we want to keep it just as part of the Bitcoin bundle.
I've not seen it used anywhere else. So, but yeah, we could definitely make it separate if we wanted to. But for now, I just and in the README, I'm documenting it. When you add this thing to multi-formats, these are the things. There's 4 things that you get.
Right. Okay, I'll just have to rethink how some of this is documented. If you look at the new docs, there's like a section where we have bundles that have like a bunch of different, like has some hash functions, some codec, stuff like that, like the basics bundle that it comes with. And then a breakdown of like each package of base encodings or codecs or whatever. And so it makes it a little awkward to have a package below that's not a bundle that has both codecs and hashing functions. So we'll just have to figure out how we want to document
just list it twice.
Yeah, I guess we can just do that. That's fine. Yeah.
It is trivial though. It's trivially implemented. So if somebody wanted it separately, I mean, they could just require it out of the library. It is a separate require if you want it. Maybe.
Yeah.
It's like how you've got SHA-2 documented there. You can do the same thing for Bitcoin slash SHA, whatever. Yeah.
Speaking of requiring things deep in a package, what do we think about ESM right now? So it came out from behind a flag in LTS node. So we're good to use ES modules in our node code now if we want to. I'm trying to figure out how much work it would be to get all of our tooling up to date. Like, I don't know what I don't think that Polendina will work. In particular,
I just want to bring up there still. So I'm aware that we are not IPFS, but I've opened an issue on the IPFS repo clarifying like which versions are supported. And there's ongoing discussions like which versions of Node should be supported and which not. And I think it is between like, so currently the current says the most recent LTS, which would be 12. And the question is if we should also, for example, support Node 10, for example. But I mention it because like, if we say we don't support 10, obviously IPFS also can't support 10. So just as a quick note.
Yeah, I mean, so last time I checked, IPFS said latest LTS. And then I don't think that they realized that that meant 12 instead of 10 now. And now they're debating whether or not they want to keep supporting 10.
Exactly, yes.
Yeah. And like, in my view, like that's not, like, don't even have that discussion. Like it's 12 now. Like it's fine if things still work in 10, but like, yeah, don't hold yourself to that. I mean, you have to like, if you don't keep up, then you're going to end up too far behind is the problem. Anyway, but the reason why this is important for us is that the multi-formats library in particular, but really across our packages, there's been a lot of, we've seen a lot of problems importing files within a package that weren't explicitly exported. And people like relying on things that weren't explicitly exported. So with ESM, you actually get the ability to explicitly export individual files and nothing else. So you can actually keep internal modules internal. And also those imports are a lot, they're less expensive now as well for importing individual exports. So anyway, that's something that we should look at as we're going along. I need, but like I said, I need to figure out where our tooling does and does not work with all this stuff. Like I was saying with Rod, like I don't know if Polendina is going to support that, like package exports, for instance. That would need to be explicitly supported by the compiler, and I don't know if the compiler configuration that we're using will support that.
I imagine that's just a configuration change, but I just haven't played enough with it with ESM.
Okay.
Maybe it's time to.
Yeah, I feel the same way. I was gonna just start porting a big library, but I think I may make a smaller library first and see how it goes.
So I would say we should like port the newer stuff, like basically. So I mean, we currently have the older stuff like the JS IPLD, the IPLD deck, PB, and so on, and we have the newer stuff like the new JS multi-formats. And so if it would be me, I would say we should port the newer stuff to ESM modules, but definitely not port the old stuff. Like the old stuff should just like stay as it is.
Agree.
And I think we could basically take the chance of, as we already have the new stuff and it will break things and people need to use new stuff, we can also just go ahead and use ESM. But I don't know if it breaks too many things then, but yeah, if I would need to make the call, I would say we should feel free to use ESM for the new stuff, but yeah.
Yeah, I'll do a small library and see what things work and which ones don't. It'll be interesting to see, for instance, if like the GitHub actions update their latest LTS quickly, things like that. So cool. Okay, that's all for me.
All right. Are there any updates by anyone else? Then, I want to just mention that currently there's also like work on the JS IPLD DAG protocol buffer stuff by Gozala, who is working on basically making it more usable and using so we already have a spec which describes the DAG protocol buffers in IPLD schema, and to align the current codec more to this, which ends up with the codec will be easier to use, and also for his use case, but also in general, and the things are shaping up and look good. I just want to basically give you this update as well, that as it is also like IPLD related. So if anyone uses the IPLD DAG stuff in JavaScript, there will be an update coming which will make things pretty much nicer. Cool. Anything else?
So if there is nothing else, I would like to bring up the, so I had a conversation with a couple of folks about the DHT, and it looks like that we actually have a pretty low hard limit on how much can we, how many discoverable CIDs we can inject into the current network, even if it grows tenfold. Unfortunately, that's one of the concerning parts. Unfortunately, we don't have like hard numbers, but this raises the question. For example, Rad's work with Bitcoin, I assume a number of the design decisions were made in such a way that you like have a transaction, you convert it into a CID somehow, and then you look for the CID. If it's not possible to put most of the CIDs in a discoverable format, how do we like deal with that? Because the current thinking on the IPFS gateways is essentially that you have some kind of root and you use that CID as a root, and then you do a name-based selector off of that, which means that when your node resolves this selector back to the root CID, it knows via bitswap who to ask, that being the currently connected peers, it knows to ask them for the CID that resolved off of that root CID. But if you just have like the deep CID of a transaction or whatever, there is nobody to give it to you. Even if somebody has it on their hard drive, there is no way for them to announce it on the network that they have that. So thoughts on this?
So I mean, there's threads going back several years now that it's not sustainable to put every CID in the DHT, like in a large data structure. And there's like a lot of different thoughts people put into for alternative discoverability mechanisms. So whether that's just like, oh hey, I'm in this network that does Bitcoin-y stuff, and like ask this network for CIDs, and that's how we're discovering people, or all the way to, okay, like let's take a selector for like a certain number of the blocks, or like a certain part of the data structure, and only put those in the DHT and use that for discoverability. But nobody's like sat down and really implemented it yet. And particularly like on the IPFS side, yeah, I don't know of anything sophisticated enough like to really do this. We're mostly like in the realm of, you know, alternatives to IPFS at that point. So
right. I was actually asking a little bit differently. And I guess this is a question to Rad mostly. When you implemented your way of breaking down the blockchain into blocks, was this basically taking into consideration that some of the parts of the blockchain are only reachable via selector and not by a CID directly?
Rod, you're muted.
Well, to start with, the way I broke it down was simply to match the way that they have built it. So it has its own built-in idea of what a hashed chunk of data is. So it's matching that. But secondly, the aim was never to put it on IPFS. I'd like to put some of it on IPFS just as an example. But I think a lot of the work that we do with IPLD doesn't account for IPFS. We treat IPLD as an independent thing that could be implemented. It could be part of IPFS, but also could be separate to IPFS. Could have its own distribution mechanism. So, that was never a constraint for this work. And thirdly, one of the goals of this work was so that you could take existing Bitcoin block IDs and transaction IDs and find them by CID in whatever storage mechanism this stuff was stored in. And so that constraint's been met. It's just that the way that Bitcoin decomposes introduces a lot of noisy intermediate blocks because of these binary Merkle trees inside of the block graph. So I mean, there's just not really much of a way around any of that to make this nice and neat. And even if you were to get rid of the noise, we're still talking a lot of transactions in every block graph. Like this is a lot of data. You could re-encode all of these things and come up with an entirely new CID for every Bitcoin block graph. But those CIDs would have no relationship to anything in the Bitcoin world. They'd just be essentially random. But you could do that and then end up only having 600,000 blocks on IPFS, and each block would contain everything. That's entirely possible, but I just don't know how useful that is.
I mean, the reality is like the disparity between the sort of maximum number of entries that you can put into DHT and the maximum number of entries that you can put into any other storage mechanism that you might use is pretty huge. Like, we're just not worried about a few million like records in any key value store or in a CDN or in any other way that we might distribute data. So we just can't really like take that into consideration when we're designing building things. I mean, just looking at the data that we've processed for the Filecoin launch, it's billions of blocks, like billions and billions of blocks. So they clearly like cannot all go in a DHT.
Right.
Yeah.
I guess I'm more like, because my understanding is that currently every CID maps to a block essentially in the Bitcoin world. Whereas there is also talk of IPLD having, what is a logical block being separate from what is like a CID addressable block kind of thing.
Well, this is the problem in the Bitcoin world, is that the terminology of block is really weird because they've taken block to mean this thing that is produced every 10 minutes, that the entirety of that thing. But it's not what they're hashing to produce the digest, to produce the address. What they're hashing is the 80 bytes. So a Bitcoin block is really a block header addressed by 80 bytes. And then you've got this graph attached to it that is other blocks. And so what I've done, and what I'm doing in my documentation that I'm writing now, is being really clear about that the definitions here and saying in the Bitcoin world, when they say block, it's not what we say with block. So I'm saying block graph to refer to what they would say as a block. It's one is produced every 10 minutes, but it is a graph of multiple blocks because they also address individual transactions, and you can go and you can query the Bitcoin Core or one of these block explorers for transactions. What are they? Well, okay, they're within a block, but they're also addressable individually. So there's this confusion of terminology I don't think was ever cleared up properly in the Bitcoin world that I'm trying to be much more clear about in this work, that there are multiple blocks within a block graph that is produced every 10 minutes. Yeah, it's messy. It's really messy. But when you break it down into, okay, what are the chunks that they produce these digests for? Then you can see that there is actually a graph, a coherent graph of what we would call blocks. And it's a single hash function, and it makes a well-formed graph, except for the SegWit garbage. It's still a graph. So yeah.
And you took like every individual node and you made it into an actual
yeah, and
IPLD, IPFS, ID block, whatever.
The main messy piece about that, putting SegWit aside, is that Bitcoin treats the binary Merkle tree that it traverses from the header to the transactions. It treats that as implicit. And so it doesn't store the internal nodes of that binary Merkle tree in its own binary format. It just says, well, that thing exists and you can compute it, and just waves it away. And so what I'm doing is actually computing it and storing it. So there's these small nodes in between the header and the transactions that form a tree, this nice binary tree. And each of those internal nodes will have its own CID, essentially, because it is there. Bitcoin does compute it, it just doesn't store it.
Yeah, I guess I'm really asking all of this to get like a better idea. For example, I don't know, for Chris's use case, right, with the medical imaging and stuff like that. That's more or less the same bag of problems. A huge tree that you cannot really, advertise directly. So like, yeah.
I view this as IPFS's problem, not ours. We want to address data. And so we're just doing that, and we're using the tools available to us, and we're trying to be agnostic about storage format, which is why in that graph, that chart about what is IPLD that's floating around, the specs repo is a copy of it in a pull request, but that has it slices out IPLD as being, the application sits above, but the storage layer sits below, and it's like, that's not our concern. And we're going to use different storage layers. Michael's working on DAGDB. We've done things before where the blocks just sit on disks, and they could just sit in a database. You can put them in S3.
I mean, car files are like basically a storage mechanism as well. Yeah.
Yeah, and I've implemented that as a queryable database. Yeah.
I mean, the thing to remember here is like, if IPFS just does something along the lines of, oh, here's a data set and here's a selector, and just the things that match the selector are what you should put in the DHT, that's enough to take the whole Bitcoin data set and then basically put in the DHT all of the block graph identifiers, which are what like Bitcoin tends to look at as its addresses. So that would be enough to like, and from there you can get anything under the graph, right? So it's actually pretty trivial to go like, oh, well, I need some data and I know that it's somewhere in this transaction. Okay, now I can find the peers that have it and then go down the graph and ask them for it, right, as I get the data. It's all fixable once those feature sets exist in IPFS, but right now they really don't. And we don't really have any control or all that much input into when that happens. So it's best to just not really think about it.
Here's the piece that really sucks with Bitcoin, is that you can take, if you have a transaction ID that you've stored because it was your transaction, and you want to look it up on IPFS and say we did seed this all into IPFS, you could get that transaction, but it would be devoid of witness data. So if there was witness data attached, it wouldn't be where you look for it, and you would have to navigate backwards to find it. So, which you just can't do. So there's no way to get from, if you only had that transaction ID, okay, I can see the transaction, but so what? I don't know what header it's attached to. I don't know how to go back up so I can go back down and find the witness data. It's just the thing in isolation. So that's the sucky bit about SegWit, is that the transaction IDs don't give you the full transaction. You've got to find the full version of a transaction elsewhere.
So it's almost like the data set actually can legit benefit from a index that is being, a reverse index that is being shipped with the data set itself.
Yep.
So this is actually starting to sound like a more generic problem where, because I have this in DagDB too, where like there are structures that I sort of attach to the side of other data. So I have like a primary data structure, and then I want to create indexes of it. So there's basically like a new block now that references both of these, the index and the primary store. And like often you may have a primary store or have an index and want to get at the one or the other, and there's no reference inside of either of those trees to each other. There's only a reference from that header that's above. So that's something where like we may want to have something in there where like, you know, related data or linked data or something along those lines where you can actually query a node for what blocks do you have that link to this block.
There's a reverse tree traversal thing here that would be generically useful.
Well, but reverse from where though, right? Because you can have n number of things that link to this, right? So you never know which one you're talking about. But one thing that like I do have in DagDB is that all of the storage layer stuff, so S3 file, like everything, it stores a reverse index. So you can always find all of the blocks that link to a particular block. And that's really important if you want to do smart garbage collection. Because that's the only way for you to go and figure out, like, was this the last thing that linked to this so that I can clean it up?
I wonder how useful schemas are with this, because they tell you the important relationships. Because there's one thing that I haven't done with Bitcoin yet, which is doable, is the links between historical transactions. So every transaction links to a previous transaction where the coins came from, and so you've got the header, which forms the headers that form the coherent blockchain of one block to the next in Bitcoin, but also within the transactions they link to each other in this sort of arbitrary manner. But there is this other DAG that links these blocks together, or the block graphs together. And it would be nice to be able to traverse from one transaction to the previous transaction that had held those coins to the previous. But they sit aside. And currently in my schemas, I don't even represent those as links yet. So that's doable, but not important right now.
Still though, from a storage, even with schemas, from a storage layer perspective, if you say, here is a CID, this is the schema that is associated with it, you still don't know what the parent was. Right? Like you only know how to attach schemas to the children of that, to whatever the root was. So and
it's not static anyway, because one provider of this could have built a completely different supplementary graph to another provider. So we almost need a selector to ask a provider like, hey, what else do you use this for? Give me that.
One thing that you could use schemas for is that if you were doing that query that I talked about earlier, where you said, give me the blocks that link to this, you could say, give me the blocks that link to this that match the schema. And then it would at least pare it down to just the things that match what you believe the parent schema is supposed to be.
Well, what about the case, like I'm thinking Bitcoin here, obviously, but where if I add a graph to like DagDB, say, then and I add it according to a schema, so I've got a set of blocks that goes in, and by the way, these set conform to this entire like the schema maps onto the set. Here's the whole lot, because that's my use case, right? Here's the whole lot of all these blocks I want you to store, and here's the schema about how they link together. Maybe you could do something clever about how they link together, and so I can query them later on.
Yeah, but like,
I know that doesn't scale to every use case, but
yeah, no, I mean, like you could always create an index, right? Like that's how DagDB handles this, right? Is it like so? First of all, what you store is always referenced from that root of that schema when you store it in the primary store. But I imagine that you're putting it into DagDB so you can get some kind of better indexing on all the values, and then those values are in an index, and the semantics there match whatever that index does, which is open-ended at this point. I mean, like the way that the indexing engine works is that it's hyper generic, so we can create indexes that look like pretty much anything.
Yeah, in the context of UnixFS, for example, it would be here is a CID of a stream. Tell me what file names or what tar files or what Docker images match this, contain this stream on your data store, kind of thing.
Yep. That again, I think would look like the give me the block that link to this that matches schema or a set of schemas.
But it's more give me like the chain of like it's not exactly the first block that links to this, but the first parent in a chain of blocks that link to this that matches the schema. In the case, for example, of a Docker image.
Right. Yeah, crazy stuff. All right. Okay, anything else before we shut it down?
I do have a quick question. I think I saw in the IPFS channel that GraphSync has been delayed. Is there any more info on that?
That's related to GraphSync and Go, though, right? Specifically, right?
No, that's specific to GraphSync in Rust. Therefore, so basically the only information is that basically the team that works on or wanted to work on GraphSync in Rust just postpones it a bit and has other priorities and will get back to it at some later point. But yeah, it's open when, so there's not more information about it.
Also, the person that was doing the work in the Go implementation is also being pulled off for something else. And also, the person that was doing things in JavaScript on our end to get it working is also no longer working on it. So I think we're just delayed like in every language for GraphSync right now.
That was my question. It seems like everything GraphSync is stopped for right now. I just want to confirm that.
Yeah. So just that everybody is sort of aware. Tim Caswell's he's got like a family of 5 under quarantine right now and everything, and so it's just been a bit too much to stay on top of everything. So his kind of part-time contract with us is ending now, and so he won't be working on the selector stuff anymore. He may come back at a later date, but like it's just sort of like up to him when he decides that he has the bandwidth to come back. So that particular selector stuff it's just getting set down for a minute while we figure out who's going to do it and when. It may end up being me at some point in time, but we'll see what the prioritization looks like.
All right. Okay, cool. I just saw it. I wanted to hear a little bit more about I think everyone knows I'm very interested in GraphSync, so was hoping to get plugged into any development there, but if that's delayed right now, I guess there's nothing to plug into. As a side note, I've been like immersing myself in Rust the past 2 weeks and am now at like basic competency. So I'm very happy about that.
That's a decent achievement.
What's that?
That's a good achievement, that one. Be proud of that.
Yeah. And yeah, I'm actually really happy because we'll get into it. But what was I going to say? Oh yeah, so I am planning for my project. I did the prototype in JavaScript, but I want to do the production stuff in Rust. So that's kind of like my new go forward stuff. So anyway, that's I guess my update.
Yeah, so just in case you want to get into Rust and GraphSync, I think, if I recall correctly, also like on the Matrix channel, there is Rüdiger, the nickname is RKLEAHN, I think, who is from Actix, who is also I think interested in GraphSync, and they also do a lot of Rust stuff. So just it might be interesting to basically catch up with him if they do anything in this regard, because like they might also look into it or basically have ideas about it, just to make sure that you basically catch up with them in case you want to get into it, that there aren't any double efforts. But this would be basically, I think, the only person currently who would, like, everyone else is not looking into it now, and he might be the only person who might currently still look into it. Yeah.
Okay. Yeah, I don't know. I got plenty of stuff to work on, so I'll probably, rather than go the Lone Ranger route, try to get plugged in once activity resumes. So.
Yep. Cool. Yeah, that's fine as well. Sure. Yeah. Cool. Okay. Then I close the meeting. So goodbye, everyone, and see you all next week. Goodbye.
I have one private thing for the team real quick
Okay.
about one of the internal policies.
Wait.
Okay.
Wait.
Sure.
Yeah.